Hello everyone, how are you all doing? Well, in today's video, we're gonna go a little more deeper into the topic matrices. So let's begin. Let's see the plan for today. Firstly, we have the transpose of matrix, properties of the transpose of matrix, symmetric matrix, q-symmetric matrix, and the discriminant of a matrix for both 2 by 2 matrix and 3 by 3 matrix. So let's begin. Now let's look into the topic transpose of a matrix. Well, it is formed by interchanging rows into columns or columns into rows. If you even do rows into columns or columns into rows, it will be one and the same. Let me show you how, and let me show you how a transpose of a matrix is obtained. Alright, now let's take one matrix A. Let's say this is matrix A, which has 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, now I'm going to obtain the transpose of this matrix. I'm going to write T over the top right top. Alright, now I'm going to obtain its transpose. That is, either I'm going to convert rows into columns or columns into rows. It will be the same. I'll show you how. Let's take row number 1, 1, 2, 3 and make it column over here. 1, 2, 3. Fine. You must be aware by now that rows are horizontals and columns are verticals. Isn't it? So when you're converting rows into columns, it means you're going to convert horizontals into verticals. So 1, 2, 3 will be written in this manner. Then 4, 5, 6. You'll write it as 4, 5, 6. Then 7, 8, 9. 7, 8, 9. Fine. This is the transpose of matrix A. So you will generally write this as A dash. Okay. Then if you look over, I already told you that rows into columns or columns into rows will be absolutely the same thing. Let's see if it does verify here, right? So here I have columns into rows. Now let's take my first column as 1, 4, 7. If I'm going to convert this into row, it will be in this manner, isn't it? Then if I'm going to convert 2, 5, 8 column into second row, then it will be 2, 5, 8. 3, 6, 9. 3, 6, 9. Isn't it same? So either you convert rows into columns or columns into rows, it will be the same. Alright. So what is the transpose of a matrix? Well, it is formed by interchanging the rows into columns or columns into rows. Moving forward, we have its properties. Let's deal with it. Now we have four properties of the transpose of a matrix. Firstly, it says the transpose of a matrix is the matrix itself. I know it seems to be very confusing. Let's take one matrix A and say it is 1, 2, 3, 4, 5, 6. Fine. Now if I'm going to take transpose of this matrix, I'm going to take the transpose of this particular matrix, that is AT. Fine. So I'm going to obtain it as, let's take 1, 2, 3 and write it as 1, 2, 3, 4, 5, 6, 4, 5, 6. This will be the transpose of A. Fine. Now take the transpose of the transpose of A. That means you'll take AT whole T. That is, you're going to take the transpose of this particular matrix that we obtained, right? So that is going to be here columns into rows. Let's do it again, right? Columns into rows. Fine, that's going to be 1, 2, 3, 4, 5, 6, 4, 5, 6. Now tell me, what is the difference between this matrix and this matrix? Aren't they same? So AT whole T is equal to 1. As simple as that. Here we have, if there's a scalar k, that is a constant basically, then the transpose of the matrix A times the scalar k, that means k times A, this transpose will be equal to the constant times the, here wherever it is written times, it's basically multiplication, alright. Do not get confused. Fine. So it is multiplied with. So matrix A is multiplied with scalar K. And constant has been multiplied with transpose of matrix A. That is what it means. Fine, fine. Alright. So here we have the transpose of the matrix times the scalar K. That is what it is equal to the constant times the transpose of matrix A. That means you're not going to, have this K in the brackets like earlier. You're going to take K out and you're going to first take the transpose and then multiply it with the K. That is what it means. Let's verify this. I know it's very confusing. Let's understand this by an example. Fine. Let's take K as 2. Let's take K as 2 and matrix as 2, 4, 6, 8, let's say. Alright. Now let's put this given data aside and quickly substitute Ka transpose. This is going to be Ka transpose. That will give me 2 times 2, 4, 6, 8 whole transpose. Are we getting? That means first I'm going to multiply 2 with each element and then whatever the matrix I obtain, I'm going to transpose it. Fine. So this is going to simply give me 4, 8, 12, 16. Now I'm going to transpose it. What do I get? I get, here I have 4, 8. So here it's going to be 4, 8. Here I have 12, 16. So here I have 12, 16. So this is the transpose that I've obtained. Fine, let's put this aside for a while. Now substitute Ka transpose, where A is the, a separate term, where K is not involved. Firstly, you're going to take the transpose of A and then multiply it with the constant term K. Fine. So KAT, that is going to give me 2. What is A? A is 2, 4, 6, 8. Transpose. Fine. So 2, here what will be the transpose? 2, 4 will be written as 2, 4. 6, 8 will be written as 6, 8. Now multiply them. You're going to have 4, 12, 8 and 16. So this is the new matrix that we obtained. Now have a look at this matrix and this matrix. Aren't they same? So this is the second property of the transpose of a matrix. Moving forward, we have the third property which says the sum of transposes of matrices is equal to the transpose of the sum of two matrices. Alright, so let's take A plus B whole T. That is, let's say A as 2, 4, 6, 8 and B as 1, 3, 5, 7. Fine. Now I'm going to do A plus B whole T. Firstly, I'm going to add A and B and then take that transpose and then verify it with this. Alright. So 2, 4, 6, 8 plus 1, 3, 5, 7 whole T. You're going to write it in this manner. This is T. Alright. So firstly add it. You'll have 3, 7, 11 and here you'll have 15. Now transpose. The transpose of this matrix that we obtained. Right? It will be 3, 7. Right? 11, 15. Now this is the matrix. Let's put this aside for a while. Right? And now let's do AT plus BT. That is, firstly take A and do its transpose. Then take B, do its transpose and then add them. We'll see if this would match. Alright. So AT will be 2, 4, 6, 8. T. Alright. What is this? 2, 4, 6, 8. Isn't it? Then I have BT. That will be 1, 3, 5, 7. T. That is equal to 1, 3, 5, 7. Now add these two. What do you get? You'll get 2 plus 1, 3. 6 plus 5, 11. 3 plus 4, 7. 8 plus 7, 15. Now have a look at these two matrices. Are they the same? Yes. So this is the third property of transpose of matrix. Moving forward, we have the product of the transposes of two matrices in reverse order is equal to the transpose of the product of them. Well, it means if you first multiply A and B and take its transpose, it will be equal to BT into AT and not. Here, one thing you're going to remember is it is not ATBT. It's not ATBT. Well, it is BTAT. Fine. Here, there is a law called the reverse law which holds in this particular property. So you can simply note it over here that reverse law holds. Fine. Now let's verify this particular property. Here let's say my A is 1, 2, 3, 4. Not being very complex, right? And B as 0, 1, 0, 1. Fine. So A, B, whole T, right? So firstly, I'm going to multiply A and B and then take its transpose. Fine. So A into B will be 1, 2, 3, 4 into 0, 1, 0, 1. Fine. This is going to be, let's take the first row and multiply with the two columns. So 1 into 0 plus 2 into 0. That will be 0, right? So my new matrix is going to have 0 as its first element. Then if I'm going to take the second column, it's going to be 1 into 1 plus 2 into 1. Okay, this will be 1 plus 2, that will be 3. So here I'm going to have 3 as my second element. Now take this second row and multiply with the two columns again. So take 3, 4 and multiply it with the first column. It will be certainly 0, right? Then take the second column, that is 1, 1. So 3 into 1 plus 4 into 1, that will be 7. So here I'm going to have 7. So this is our matrix. Now you're going to take its transpose. Okay, do not forget to take out its transpose, right? So its transpose is going to be 0, 3 will become 0, 3 in this manner and this will become 0, 7. So let's put this aside for a while. 0, 0, 3, 7. Noted. Now let's take BTAT. Now B2 into AT, right? So BT will be what? What is the transpose of B over here? 0, 1, 0, 1. What is the transpose of A? It will be 1, 2, 3, 4. Now multiply them. Remember that you're going to multiply BT into AT and not AT into BT, right? So that will be 0, 0, 1, 1 into 1, 3, 2, 4. Let me make a quick erase here. Alright. Now let's multiply A and B. Fine. So firstly take the first row and multiply with the two columns. That is going to give me 0 into 1 plus 0 into 2. That will certainly be 0. So here I'm going to have 0 as my first element. Alright. Then I'm going to take with row 2. I'll certainly have 0 again because 0 multiplied with anything will be 0, right? Again, if you add them, you'll get 0, right? Then I'm going to take the second row and multiply with the two columns. So here I'm going to erase them. Fine. So here I'll have 1 into 1 plus 1 into 2. This will be 1 plus 2, that is 3. So here 3 will be my third element. Then do it with the second column. That will be 1 into 3 plus 1 into 4. What will this be equal to? 3 plus 4, that will be 7. So here I'm going to have 7. Now, have a look at this answer and this answer. Aren't they same, right? So they are same. So this is the fourth property of transpose of a matrix, which means the product of the transposes of two matrices in reverse order is equal to the transpose of the product of them. Here, one thing that you're going to note here is that it is in reverse order. Moving forward, we have the symmetric matrix. Let's see what it is. Symmetric matrix. A square matrix A is said to be symmetric if A transpose is equal to A. Symmetric is basically mirror image that we previously studied in our lower classes, right? Now, what is a symmetric matrix? Let's bring on an example to understand it way too better. Here, if you look at this example, take a look over the lower triangle and the upper triangle. Now, if you look at their, the numbers or the elements that are present in this triangle, they are quite same, isn't it? Not even similar, they are same. So that is, they are the mirror images. Fine. So such a matrix is known as a symmetric matrix. Now, if I tell you, please build me a symmetric matrix, then without any delay, you'll make sure that all the diagonals must be different, same, whatever it is. Diagonal is none of our concern in this symmetric matrix. But whatever is gonna be here, let's say I'm gonna put on 0 over here. I'll have 0 here, right? A straight arrow. And then if I put over 1 over here, then here I'm gonna have 1. Straight again. If I put 2 over here, I'm gonna have 2 here. Straight again, right? In this manner, I'm gonna build my symmetric matrix. Fine. If I tell you to build a symmetric matrix with the numbers being 2, 3, 4, right? Let it be wherever. Okay. Now, this is my matrix. I'll take whatever the diagonal I wish. 1, 6, 8, let's say. Now, here I'm gonna have, let's say, 2. Okay, here I'm gonna have 2. Then here I'll certainly have 2. Fine. Let's say here I'm gonna put over 3. Here I'll have 3. Here I'm gonna put over 4. So here I'll have 4. In the same line that is I want to say. Alright. And remember that diagonal elements are none of our concern. Diagonal elements have nothing to do with the symmetric matrix. Let's move on to the skew symmetric matrix. Moving forward, we have the skew symmetric matrix where A transpose will be equal to minus A. What does this mean? Now, if you look over this matrix right over here and take a look over the triangles, the lower triangle and the upper triangle. Now, if you observe, their signs got changed over here. Here it's 1, here it is minus 1. Still they are straight. Minus 2, 2. Still they are straight. 4, minus 4. Still they are straight. Here one thing that you're going to notice that the signs get changed. That is the only difference that you find out between skew symmetric and symmetric matrix. Alright. So here what is the thing that you're going to note? The signs of the numbers, they are different. Okay, they are completely opposite. Fine, if it is plus, then it will be minus over the other side. If it is minus over the other side, then it will be plus over this side. So in this manner. Fine. Now let's build a skew symmetric matrix with the numbers, let's say 7, 8, 9. Alright. So here I have the matrix. And remember that all the diagonal elements present in the skew symmetric matrix are equal to 0. Whereas on the other hand, in symmetric matrix, that was none of our concern. But here, all the diagonal elements in skew symmetric matrix are equal to 0. Alright, this is the difference over here. Alright, so firstly, put all the diagonal elements as 0. Then take 7 over here. You'll write minus 7 over here. Alright, if you take 8 over here, you'll write minus 8 over here. On the other hand, if you take minus 9 over here, you'll write 9 over here. Fine, have a look at them. Minus 7, 7, minus 8, 8, minus 9, 9. This is how you'll form a skew symmetric matrix. Moving forward, we have the determinant of a matrix. Well, let's say I have a matrix A, which is 2, minus 9, 1 and 5. Of the order 2 by 2 again. Okay, we're only dealing with 2 by 2 right now. In the next slides, we're going to discuss about 3 by 3 matrix as well. Alright, so here, if I have to find out the determinant of matrix A, I'll write it as that A is equal to. Now, draw a diagonal first. Draw the diagonal first. Multiply the diagonal elements. 2 into 5. Multiply them. Alright. Multiply the rest of the elements and subtract. As simple as that. Okay. Firstly, multiply the diagonal elements. Then, multiply the rest of the elements. Subtract them. As simple as that. Fine. So, here it's going to be 10 minus of minus 9, that will be 10 plus 9, that is 19. Now what is the determinant of matrix A? The determinant of matrix A will be 19. Now for a 3 by 3 matrix, you got to memorize this table. And it's not necessary to memorize the entire table, but the row you choose. Let's suppose say I choose row 1, then you got to memorize this part. If I choose row 2, I got to memorize this part. In that manner, you're going to memorize the data. Let it be you choose a column, then you got to memorize this part. Alright, in that manner, you can memorize this stuff. Alright, but it's not necessary to memorize the entire stuff that is in the table. Alright. So let's say I'm going to choose row 1, that is 0, 1 and minus 2. Okay, then I'm going to memorize this part. Alright, done. So plus, minus, plus is something that I got to memorize. Alright, fine. Now take the first element, that is 0. Now 0 is a part of one row and is a part of one column. So simply cut this part. Cut the row and column that it belongs to. Then you will be left out with a 2 by 2 matrix. You will be left out with a 2 by 2 matrix. And remember, 0 should be multiplied with it. Whatever you're going to do here. I'll tell you what to do. Firstly, multiply 4 and 0. Firstly, multiply 4 and 0. Why are we multiplying 4 and 0? Firstly, you got to multiply the diagonal elements. Alright. Then you'll subtract it with what? You got to multiply 4 and minus 4 right now. 4 and minus 4. Now 0 into anything will be 0, right? So irrespective of what you get here, the answer is 0. So write down 0 over the top. Right? Then take the second element in that particular row that you choose. Right? 1. 1 is the second element. Now cut down all the rows and columns that it belongs to. Definitely it's going to belong to only one row and one column, isn't it? Alright. So here you will be left out with a 2 by 2 matrix. Minus 1, 4, 2 and 0. Now multiply the diagonal elements. Multiply the non-diagonal elements. Subtract them. So minus 1 into 0. Minus 4 into 2. So this will be 0 minus 8. That is minus 8. But remember to multiply the element that we chose, right? You got to multiply this with 1. You got to multiply this with 1, right? Simply if you multiply the answer with 1, it will make the same stuff, alright? So write down minus 8 at the top. Minus 8 into 1 is minus 8. So write down minus 8 at the top. Just note down all the numbers because they have a huge to do with your problem. Alright. Now take the third element. Cut down all the rows and columns. Now you have a 2 by 2 matrix. Multiply the diagonal elements first. Subtract the non-diagonal elements. Wholly you got to multiply it with minus 2. Fine. Here you'll have, what is minus 1 into minus 4? It is 4. Minus 8. Alright. This is minus 4 into minus 2. What is this gonna give me? This is gonna give me 8. So let's write down 8 at the top. Fine. Let's erase all the stuff that is on the screen and let's get back to those three numbers that we got. 0, -8 and 8. Now this right over here seems to be very much important. Look over here. Whatever the signs that we choose, right, put over the numbers that is there. Here +0, here we had plus, right? So whatever the number it is, you got to put plus. But it does not make a sense over here even if you put +0 or -0, right? Because 0 is neither negative nor positive. One thing that you got to remember. Let's say in case of 0 you have 4, right? Then it will be +4. Again, it does not make any difference. Let's say you have -4, then you got to convert it into 4, right? No, that's not the case, right? If you have -4, then you'll be having plus of -4. That will be -4. Fine. All right. Now that is have nothing to do with the 0, right? Then you have minus. So you got to subtract. Put over this -8 into brackets. Then you have plus. So +8. Now this right over here will become 0 + 8 + 8. This will become 16. So now what is the determinant of this matrix? Let's suppose say this is matrix A. Then what is the determinant of this matrix A? It is 16. Did we all get that? Well, if you haven't grabbed the previous problems that we discussed, do not worry. We'll be definitely covering in the next videos that we proceed to. And that's all for today. Make sure you hit the like button, share and subscribe. Thank you.